Let's take a look at example 1, find and simplify the indicated derivative. So we're given f of x equals 5 times the cosine of x. We're asked to find and simplify f prime. So f prime of x is asking us to find the derivative. So we're taking the derivative of 5 times the cosine of x. And now we can apply our derivative properties. We have a constant multiple of 5, so we can factor that out front. So we've got, 5 times the derivative of cosine of x. And the derivative of cosine is negative sine. So 5 times negative sine of x. So we get negative 5 sine of x. And that's the derivative for the first example there. Next one, we have y equals x squared sine of x. Find and simplify dy dx. Remember, dy dx is another notation for the derivative. So dy dx equals the derivative with respect to x of x squared sine of x. And remember, x squared sine of x is really x squared times sine of x. So we have a product here. So we apply the product rule. Now take the derivative of the first factor, x squared, times the second factor, plus the first factor times the derivative of the second factor, sine of x. The derivative of x squared is 2x, so I have 2x times the sine of x, plus x squared times the derivative of sine x, which is cosine x. And so that's the derivative here for the second function. The last one here, we've got f of theta is sine of theta divided by 1 plus the cosine of theta. We're asked to find f prime of theta. F prime of theta is the derivative with respect to theta of sine of theta divided by 1 plus the cosine of theta. And we see here we're going to have to apply the quotient rule. So we identify low function and high function. Here we go. We've got low d high. So 1 plus cosine of theta times the derivative of sine of theta minus high d low, sine of theta times the derivative with respect to theta of 1 plus cosine of theta. And we square the bottom, and off we go. So we get the quantity 1 plus cosine theta squared. So let's run through this here. We've got a 1 plus a cosine of theta times the derivative of sine theta, which is cosine theta, minus the sine of theta times the derivative of 1 plus the derivative of cosine theta. Derivative of 1 is 0. Derivative of cosine of theta is minus sine of theta. This is all divided by 1 plus the cosine of theta squared. Now once again, don't go cancel crazy. You can't cancel the 1 plus cosine and the 1 plus cosine. In order to cancel out of a numerator, we need it to be a factor of all the terms. We need to be able to factor it out from everyone. So instead, we're going to simplify the numerator and then see if there's some cancellation we can do. So let's take a look at that numerator. We can distribute here to get cosine plus cosine squared theta. And now we have a minus sine of theta times minus sine of theta. That's a plus sine squared theta. And this is all divided by 1 plus the cosine of theta squared. And hopefully you recognize cosine squared of plus sine squared. We've got some Pythagorean magic there. Cosine squared of an angle plus sine squared of the same angle gives you 1. So the numerator now, we've got cosine of theta plus 1 divided by the quantity 1 plus cosine theta squared. And now if we rewrite the numerator, cosine of theta plus 1 is 1 plus cosine theta. You say tomato, I say tomato. 1 plus cosine theta squared. And now we can see what happens. We do get some cancellation, but now it's legal. We're left with a 1 in the numerator. And so when it's all said and done, we get f prime of theta is 1 divided by 1 plus cosine of theta. So that'll do it for example 1.